Okay, so MCM-2 neutron backscatter gauge. The components you should have available are the standard block, the pole, the scalar, the gauge head, and of course that comes with the pole attachment and a scalar connector pole connect. All right. Now, a couple things about this gauge. You have to take into account the pipe size. That depends on neutron backscatter. For a smaller pipe, of course, you're going to get a smaller response because the neutrons escape. So pipe size has to be taken into account. This shows basically the basic setup of using the pole. Okay, as far as neutron backscatter, a neutron backscatter method depends on hydrogen because it really is a hydrogen detector. And the more hydrogen you have, the more hydrogen per unit volume you have, the higher the count rate will be, or the higher the number of counts for a certain period of time. Water contains a lot of hydrogen, but there are other things that contain hydrogen. Concrete will contain hydrogen. So if you're measuring on a pipe and you got a big concrete block close by, that can influence what you measure. So you have to be careful about what things might have hydrogen in them when you're taking these measurements. As far as neutron, the amount of collisions to thermalize, the reason this is important is simply because the detectors that actually detect the neutrons can only detect slow neutrons, what we call thermalized neutrons. And the number of collisions required to slow down the neutrons that are emitted from the source, which emits fast neutrons. Okay, for steel, it's 514, carbon is 112, but for hydrogen, you jump down there at the bottom, you see it's only 18. So that's why you get such a large count out of the hydrogen. Now, this gives you kind of an idea of various response to various insulations, okay? This assumes that there is no hydrogen-bearing material within the pipe itself, that the pipe is void or empty. And you can see that there is big response difference for saturated versus unsaturated. And it also depends on the type of insulation that you have. Okay. This is a response with certain different fillings of the pipe. And this is the actual counts on this side that we obtained. And if you look here, the way this is interpreted is this is what the insulation, this is the pipe fill. So this would be dry insulation, dry pipe, nothing in it. And so this is wet insulation, dry pipe. So if we look at those two, let's just look at the first two here. We see that there's a fairly good response difference for the dry pipe and wet insulation dry pipe. Okay. In each of these cases, it's reasonably good. But when you move over to dry insulation with a water-filled pipe, wet insulation with a water-filled pipe, you see that they're fairly close together in these readings, especially up here where this was a 300 millimeter phantom sample against a pipe insulation. And you see that there's not much difference in terms of the value here. And if you were to calculate the uncertainty or the uncertainty in those counts, you would see that based on the uncertainty, they're pretty much the same. So this here just basically looks at the ratio of the counts for wet insulation to counts for dry insulation. And we can see here, of course, 1 here, and it really blows up here on this first one. Factor of 1.8, factor 1.4 here and a factor a little bit over 1.4. But you get down here to where the pipe has water in it, and you see you're only about 1.1 here, maybe about 1.05, 1.03 here. So very little difference between the wet insulation and dry insulation. That depends on what amount of saturation there is, of course, but you just have to be careful about what is actually in the pipe. If you do a base measurement with the pipe empty, and then you move over to a region where the pipe has some hydrogen-bearing material in it, you could get a false reading. So when you make a base measurement, and a base measurement is going to a point on the pipe that you know the state of the insulation in the pipe itself. You know that the insulation is dry, and you know that the pipe has no hydrogen-bearing material in it. And so I can get a base measurement and use that to compare other regions of the pipe. And the assumption, of course, behind that is that when I'm comparing those regions, each region in the pipe that I compare is similar to the region I did my base measurement on.
Okay.
Okay, does that make sense? Okay, so for an individual test, we want to start a count, okay? And basic process here is just to hit the start. And you'll see it come up on the gauge front as counting, and then it starts counting down, XX seconds, X minus 1 seconds, all the way to 0 seconds. Okay? Counts for the time, or the time of counting, has been previously set. Okay? Now, all these counts, if I set a count time of 15 seconds, or a count time of 1 minute, or a count time of 4 minutes, the way the gauge has been set is if I put it on exactly the same thing and I'm measuring exactly the same thing, then regardless of whether I count for 15 seconds or count for 1 minute or count for 4 minutes, I get exactly the same counts. What does improve is my precision, okay? My uncertainty, as I use longer count times, my uncertainty gets smaller. Okay?
Yeah.
To evaluate the uncertainty in the counts, I can use whatever my scaled counts are divided by the pre-scale. Okay? Where my pre-scale is based on 60 seconds. So if I count for 15 seconds, 15 divided by 60 would give me a pre-scale of 0.25. If I count for 4 minutes, which is 240 seconds, then pre-scale is 240 over 60, which would give me a pre-scale of 4. Okay. So I can evaluate real quickly what my uncertainty is in the count and compare that to a region I'm studying, I'm looking at to see if it's outside that uncertainty. This is a normal 99% confidence interval. As an example, if my count is 500, my pre-scale is 0.5, my count should fall between 405 and 595, 99% of the time, for exactly the same measurement of the same area or equivalent area. Statistics, okay. Unscaled counts follow the counting statistics, but we deal with scaled or pre-scaled counts. Okay. All right. And you can always estimate the uncertainty based on the square root of the counts divided that you see on the gauge divided by the pre-scale. Okay, to obtain a standard count. Okay. Now, anytime if you want to get the scaler and push the buttons, you let me know. Okay. For a standard count, you just basically place the standard block on the case itself, and then place the gauge head on top of the standard block. And that's the geometry for a standard count. Okay. Of course, the telescopic pole allows fairly easy access. Notice here that this one is on the ground, very close to the ground, and it's important to point out that if the ground is saturated with moisture, you're going to have a difficult time deciding whether you're detecting moisture from the pipe or moisture from the ground. Okay, so you will need to, in this case, you will need to make sure that you have a good reading of the pipe, of a dry section of the pipe at the position where you're going to be measuring it, so you can make good comparisons. And this one is an easy one, because in this case, the only thing you have next to it is this steel pipe. Steel pipe is not going to give you a problem with counts. And so you're going to get a good measurement off this section of the pipe. You do have to be careful around a corner. That can affect the results. Okay. The other thing is, of course, you're always comparing to the same pipe fill. This shows for being used on vessels. A vessel is probably an easier section to calibrate than a pipe, especially if you're going around this whole thing. If you have a good dry section that you can measure on or get a base count on, then that comparison is fairly straightforward. In this case, you can extend the pole up to 10 feet. Just watch the wiring. Make sure it doesn't get hung on something. This little protrusion right here that you can see would be a culprit to catch the wire. Okay. Once again, be careful about going around a corner. Try to find a place as flat as you can. If you look at the way the gauge head is up on this, it's not up very well. It needs to be pressed against the material as well as you can. As far as the advantages of the neutron backscatter, it is a good rapid screening tool. It can be used while the process is operating if that's what you want to do. You just have to get a good base calibration or base check. The telescopic pole allows quick access. And of course, it can be used on vessels and for level detection. If you have a vessel that has a hydrogenous material in it, you will note that hydrogenous material very quickly where the level is, because the counts will change very quickly. This gauge easily goes through a 1/4 inch, 1/2 inch of steel without much of a problem. Okay. Limitations of this gauge is that it detects water. It detects hydrogen. It does not detect corrosion. Okay. It will also detect other hydrogenous material if you're next to a pipe or something like that. Variations in insulation and pipe configuration do require some operator interpretation. So you need to take into account the pipe and the insulation size, the insulation porosity. If you're actually trying to calibrate some sort of volume percent, you want to make sure the operator knows the dry response, and of course, take into account the pipe contents. Variations that may affect the reading include the location. Notice here, this particular gauge head's measuring with another pipe containing hydrogenous material. There's no way for the gauge to know whether it's reading moisture from the insulation or it's reading moisture from this actual pipe containing hydrogenous material. If you move to a different section of a different insulation section, your response can change. In that case, it may take some interpretation to figure out whether this count is due to an insulation change or due to actual moisture content in the jacket or within the installation. Okay. Gaps in insulation can also change the count. Okay. However, if you have gaps in insulation or more volume, your counts and the pipe fill remains constant, then your counts will probably go down, which will not be too much of a worry, because really you're looking for your counts to go up. Changes in pipe contents, of course, this, if you're moving from this region over here where the pipe's empty and all of a sudden you're into a region where the liquid level changes, you're going to get a huge response change. And so you'll have to evaluate, well, is that due to moisture in the insulation, or have I moved to a region where the pipe was not drained properly? Of course, if there's a concrete barrier or the ground is very close and you're trying to measure underneath, you'll have to account for the response due to the concrete barrier or ground. Pipe size and feel, okay. If you look at these different pipes here, what I've given is a pipe that has the saturation, partial saturation within a certain volume, a smaller pipe with complete saturation, okay? Then the same pipe over here with a complete saturation, but only partially filled. Each of these give exactly the same response, okay? It tells you that there is water there. It doesn't tell you how it's distributed. It just says, yes, I see water.
What I'm doing right now, one of the things you want to do every day before you use the gauge is you want to take a standard count. So I've got the shipping case. I've got we call this the handheld. This has all the keypad and everything that you're going to be pushing the buttons. This is the gauge itself. We've got just a smaller handle on here just for testing. It's easier to hold on to. But in your case, you're going to have a standard block. So to do a daily standard count, and I'd recommend you get a log book. Take a standard count and log that in every day so you can keep up with that. That will ensure that the gauge is working correctly. And you want to orient it the same way each time. So I usually go by the little keypad here where you turn it on and off. I have it facing towards the front of the case with the latches. And you want to try to do that same way every time. On the keypad, there's a standard button. You just press standard. It'll automatically take the standard count. It'll come up at the end and give you an actual moisture count. And that's usually going to be a pretty high number, usually, around 19,000. So that's one of the most important things you can do every day. On the gauge, it has some diagnostics in here. So you press menu, option 6, and it has a diagnostics menu. I would keep up with your battery voltage each day. So there's an option 7 for battery diagnostics. You just press 7. It's going to give you your handheld battery voltage, and it's also going to give you your base voltage. That's in here. There's a battery in here. You're using Bluetooth, so this thing, it's communicating, it's using a lot of energy. So when the battery voltage does get down low enough, it's going to come up and give you a warning that the batteries are low. So one of the things you can do when you take a standard count each day, go into that menu, look and see what your battery voltage is, write down the handheld and the base unit, what it is. And over time, you'll be able to see how long that gauge will run off of each charge. You want to do this daily. Whenever you're using the gauge, you want to do it in the same place. You want to make sure there's nothing, you're not sitting right up against the wall. There's nothing within, say, 15 feet of the gauge. Even when you're taking a count, just back off of it because it will pick up the moisture in your body. If I stand right next to it and take a count, it's going to pick you up. Those are the first things you want to do each day. Now what we've got set up here is kind of we've got like insulation and we've got a pipe. We've got some bottles of water that we're going to put in there. So I'm going to kind of show you first thing to find out a baseline. And on the keyboard or your handheld, there's a baseline key. So we know this is empty. We know this insulation is dry. We're going to take the gauge. We're going to set it up on here. The longer your time, the more accurate the gauge is going to be. So if you set the time for 1 minute, there's a time button on your keypad. If you set it for 1 minute, when you do your baseline, it's going to be 1 minute. If you set your time for 15 seconds, your baseline is going to be 15 seconds. So what I'm going to do here is I'm just going to take a baseline. You're going to press that button. It's going to say, place the gauge against the reference, which is our pipe, and press start. It's going to take a 60-second count. So this is going to kind of tell you, we know that this pipe doesn't have anything in it. There's no water in the pipe. There's no water in the insulation. This is kind of your baseline. You know this is dry. And I kind of know what this count's going to come up, but it's taking a 1 minute count. So my base count on this was 489. So we know that's the dry point. That's a moisture count of 489. So what I'm going to do now is I'm going to simulate like this pipe has water in it. I'm going to slide that in there. I'm going to change my count time, and you can change this count time all the way down to 1 second. But like we said, the longer the count time, the more accurate it will be. I'm going to set my time. It's going to ask you, do you want to use this baseline? You say yes. So that's stored that in there. I'm going to change my time to 15 seconds. I'm going to press enter. So now my count time is set to 15 seconds. And I'm going to press start. And my count came up to 2,464. So the counts jumped up by 2,000 counts. So it saw through that insulation, through that pipe, and saw that moisture. Now, after this one got through taking the count, you heard that beep. If you go into the menu, you can go in and set up an alarm setting. So if you want, what your baseline count is, you can set up a percentage of those counts. So you're going along, you got a big long pipe, you're going along taking readings, and you say you want, if it's over 5% of what your baseline is, it's going to come up and give you an alarm. That's telling you that it's finding moisture. So your counts have gone up 5% of what the dry baseline count is. There's another function in here called logging. I can set up a logging where it will just sit there and take counts. Usually I set if you're going to do that logging and you want to do it quick, you can set your count time to 1 second. And then you can start logging, and it will take counts. It'll take a 1 second count. It'll just keep taking those counts as you go along. And it will come up and give you a count and an average. So that's that logging function, I would use that a lot too. If you're going along quick scanning, that's probably the best thing. And you can set it for 15 seconds, 1 second, whatever you want to set it at. So if you have no water or anything in the pipe, and you've taken your baseline count, we've got this cut out. And I'm going to put just a little pack, it's just a little bag with water in it. To kind of simulate the wet insulation. And I'm just going to take a count here. So I got a count of 720, whereas our baseline count with it dry was 480. So it picked up that little bit of moisture in that insulation. With this gauge here, a real dry count is around 400. So, if you're going along and you start seeing those counts start going up, and if you set that alarm, it's gonna say, hey, something's changed. This is a full pipe. I just put 2 bottles of water in there. I'm gonna take this out. That's my wet insulation. So what I'm gonna do is I'm gonna take a new baseline. So I know this pipe is full. So what I'm gonna do, I'm just gonna hit the baseline key, press start. I'm gonna change my count time. Like I said, the higher the count time, the more accurate it's gonna be. I'm gonna take a 60-second baseline. And I would recommend that. Every time you take a baseline, take a 60-second baseline. So now it's taking a baseline. So this is a baseline with the pipe full, insulation dry. And you'll see that our baseline before with no water in the pipe was 480. So now with the pipe full, dry insulation, you're probably gonna see this jump up 2,000 counts. One of the biggest thing I see, with some of the units that are coming back is just some of the screws and stuff. Keep an eye on your screws and stuff, because you're gonna be manipulating this thing, a lot. So just keep an eye on those screws and stuff. Every day you do a standard count, just check and make sure all your screws and everything are nice and tight. So we got a reading of 2,900 for a baseline. So now what I'm gonna do, that's with the pipe full of water, dry insulation. So now what I'm gonna do is I'm gonna simulate. So you're going along, taking readings. I'm gonna take a reading. I'm gonna leave it at 60 seconds. So now we got like 2,900 with it dry, with water in the pipe, dry insulation. I put the little water packet in the insulation and went up to 2988. So that's 80 counts difference. So that it came up with an alarm. That's 5% more than what the baseline is.